Let's take a look at another kind of problem involving arithmetic sequences. In this problem, we're asked to find the 100th term of a list of numbers, 5, 8, 11, 14. And we know that this is an arithmetic sequence because the consecutive numbers are just 3 more than the previous number, okay? So since we have a common difference between consecutive numbers, it's an arithmetic sequence, okay? So, and we're asked to find the 100th term. Well, we could, just keep listing, adding 3 and adding 3 and adding 3 and listing them all out. But let's see if we can find an easier way. So I'm going to make a little table here. I'm going to call one column of the table n, which is just that'll just be the number of the term in the sequence. So for n equals 1, that's the first term. N equals 2, that's the second term. Okay, I'm just going to number them. 2, 3, 4, and so on. Okay. And I'm going to call each term an. So a1 would be, in this case, this is the first term, so that's 5. And then we have 8. But that's just equal to 5 plus 3, right? And the next number is 11. But that's equal to 5 plus 3 plus 3, okay? Which is equal to 5 plus 2 times 3, okay? Next number is 14. And that's just equal to 5 plus 3 plus 3 plus 3, okay? We're just adding another 3 every time. So that's equal to 5 plus 3 times 3, right? So to get any term in the sequence, we take the initial number plus a multiple of 3, right? And the multiple that we use, here we have 1 times 3 for the second term. Here we have 2 times 3 for the third term, 3 times 3 for the fourth term. So you can see that the multiple of 3 is essentially lagging by 1 from the term in the sequence. So if we want to find the 100th term, we are going to take 5 plus some multiple of 3. Okay, I'm going to put 3 here. What's the multiple of 3? It would be 99. Okay, because the number of 3's that we add just lag by 1 from the number of the term. Okay, so if we were to add this, or multiply this out and add it up, we get 5 plus 297, and that's equal to 302. So the 100th term of this list is 302. And I might note too that oftentimes when you have a number that's really close to 100 or some other easy number to multiply by, 100 times anything, you just add a couple zeros. But I kind of like to think of this as 100 minus 1. And that way I can take 3 times 100 minus 3 times 1, and then you can get 297, rather than multiplying out 99 times 3. Just a little trick. So look for those kinds of tricks when to make your arithmetic quicker and easier. Okay? So let's take a look at another problem. Actually, you know what? Before we do that, I want to look at a general case. Let's look at a general case where we have an arithmetic sequence. And I'm going to define some variables. I'm going to say n is just like we have here. It's the just like the we defined it up here. We'll say n is equal to it's the, how should I put it? The it's the number of the position in the sequence. Oops. Sequence. Okay. So n equals 1 is the first term. N equals 2 is the second term. Okay. And I'm going to define too a n, as I did up here, is just the nth term in the sequence. And I'm also going to define something called d, which is the common difference between consecutive numbers. My handwriting's getting a little sloppy here, but so if we have these defined, then let's make another table like we did before. So we'll have n and we'll have an. Okay? So this is 1, 2, 3, 4. So the first number in the list is going to be a1, right? The next number in the list is going to be a2, but that's just going to be a1 plus d. Okay? Because in an arithmetic sequence, we just add a constant number each time. Okay? So a3 is going to be a2 plus d, which is just a1 plus d plus d. Okay, so we're just adding another d, so that's just a1 plus 2d. a4 is going to be a1 plus d plus d plus d. Okay, that's a1 plus 3d. All right. So let's see if we can find a general formula for the nth term in the list. So let's say n. So an is equal to a1 plus some multiple of d. And the multiple of d is going to be n minus 1, right? Because we're just lagging here. So the fourth term, we've added d 3 times. The third term, we've added d 2 times. Okay. If you look at the 68th term, it's going to be 67 times d plus the first number. Okay. So here we have a general formula for the nth term in the list. So if we want to find the 100th term of anything, we just plug in 100 for n. So if we were to do that up here, we could get straight away that an, or a100, I should say, is going to be 5 plus 100 minus 1 times the common difference, which is 3. Okay? So that's a nice thing to know too. And you know, you really don't have to memorize this formula. You can reason it out because if you have an arithmetic sequence, you're just adding d each time. And it's important to understand what you're doing in order to remember, I find. So make sure you understand it first. And then after you apply this a number of times, you're going to remember the formula. You won't hardly even need to think about it. But the first few times, it's probably best to think about what you're doing, and then after a while, you'll just remember the formula. So I'm going to pause here, and we'll work on some examples to apply this formula in the next part.